in 2005, MSD entered into an agreement with the NEA to reduce the city's stormwater retention by 98% by 2020. And so this is part of that effort. It's something like a $1.1 billion project, of which this project, the tunnel project, is a huge component. So the point of the tunnel is that it's basically a giant underground storage container. It's about a little over 4 miles long. It's 200 feet below grades, and it actually runs underneath the Ohio River. And so the Rowan Pump Station building is the primary access point into this tunnel system. And so we were initially tasked by the waterfront to look at how we might envision this large piece of infrastructure, the building component, and how that might integrate into the future Phase 4 of Waterfront Park. And so how do you make something that is completely utilitarian and transform that to something that might be an element that is in keeping or fitting with the new Waterfront Park Phase 4. The building itself was originally designed by HDR, who did the primary engineering for the tunnel project and the shaft and so on. And the waterfront had come to us to see how we might re-envision the facade, again, to be in keeping with the future design of Waterfront Park Phase 4. And so we had looked at, and so our task really was to design the facade, the exterior skin of this building that is essentially a simple block. And so we had looked at, in relation to our other efforts in designing Waterfront Park Phase 4 structures, we had looked at a lot of regional and local precedents as far as what it is to build along the river. Obviously there are things like barges and sort of these large-scale infrastructural elements like bridges and so on, which are really quite amazing. And so we had also looked at things that were more sort of poetic in relation to the river. So this kind of imagery of shimmering water when the sun sets along the Ohio River. It's a really beautiful image. We had also looked at things that are sort of related or you associate with aquatic or water environments. So one of those things was the Fresnel lens, which is the lens that you see in a lighthouse. And it has a very specific corrugation pattern that basically is designed to emit a small point of light in the most efficient way possible. And so we began to look at this building, we began to reimagine it as a kind of lantern along the river. And so how might we reimagine this piece of infrastructure as a large-scale folly, in a sense? And so we developed a lot of concepts initially, but because of the scale of the building, we really wanted to design something that was, for the sake of economy, something that was really quite simple, but also felt custom and custom-made and specific to this site. And of course, because this is also a highly public context specific to Waterfront Park Phase 4, there needed to be a great attention to issues of durability, vandalism, kind of resilience of the building, of course, minimal maintenance. And so how do we incorporate all of those sorts of issues into this building? And so there's already a kind of a material palette that exists in Waterfront Park. There is Corten steel, also known as weathering steel, which is a very durable material because it resists graffiti and vandalism. If it has graffiti, all you need to do is sand it and the patina comes back. There's also things like anodized aluminum, which is already a part of the material palette for the original phases of Waterfront Park. And so we use these two materials, a lot of which really there's great properties associated with these. One is that, of course, both materials are recyclable, completely recyclable. There's minimal to no maintenance required. And there's a lot we can do with it. We also looked at modules and using standard modules to minimize material waste. And so within this project, there's actually a lot of sustainable ideas that are implemented, but implemented in a very simple way without using sort of mechanized systems and so on. And so, in terms of, again, relating back to durability, we were also concerned about insects nesting and things like that, icicles forming, and so a lot of the choices here and the detailing of the skin addresses those. A big part of implementing the design was really working with the metal fabricator, and they were really a great team to work with, which was Merrick Kemper. They began doing full-scale mock-ups for us. We had done initially 1/3 scale mock-ups within our office, but they were the ones who did the full-scale mock-ups. And I would say the one big change was really to increase the gauge of the perforated corrugated facade. Once we jumped to the full scale, we needed to go up just a little bit to a thicker gauge. But otherwise, the design was pretty much implemented as drawn. They were really a great team to work with. We can't be more thankful for them in terms of really being a team player and collaborator and making this come to fruition. So the facade is basically comprised of just a little over 2,100 metal panels, of which a little over 1,900 of these panels are all custom profiled, perforated, anodized aluminum panels in 2 perforation densities. And so the perforation density is what causes this sort of shimmery effect of the facade. So it's not a uniform look. It actually has a very sort of specific variegated form. Each one of these panels is on a module, again, to maximize, or I should say minimize, the amount of material waste. So all of these panels the aluminum panels are mounted onto these Z-girts that are then mounted onto the CMU block wall, which is behind that. So there's actually a cavity behind all of these perforated panels. Within that cavity and all along the perimeter of the building, there are LED lights which can change colors, which wash down the cavity, the inner cavity of this building, so just behind the perforated aluminum panels. And what that does is it causes, in the evening hours, it has a very sort of soft kind of wash of the building from at its brightest point at the top of the building, and then sort of forming a gradient down as you go to the lower part of the building. And so again, when you're looking at this from the exterior or from other parts of the city, it really appears as a kind of lantern in this landscape. And also, again, as I mentioned, our precedence has that kind of shimmery effect of sort of the same effect as looking back at the Ohio River during sunset hours. The profiling, which probably you can see sort of most clearly at the edge here, again is based on the Fresnel lens, which is the glass lens that you see typically in lighthouses. And so this has a very specific corrugation profile. We didn't really want to use standard corrugation profiles because at the scale of this building, that kind of profiling would basically just disappear. So we really had to ramp up the scale of this corrugation so that it could be visible, again, in relation to the scale of the building, but also visible from elsewhere in the city. So the scale of the corrugation, the custom corrugation, was really important. And so the Corten panels, which occurs up to the 10-foot level, again, since this will be in a future phase 4 of Waterfront Park, this is all going to be within a very public setting, and so it needed to be very durable. So the Corten steel basically resists things like graffiti and so on. So again, if this was like spray painted, you literally just need to sand this off and the natural patina comes right back. So again, durability, ease of maintenance, it was a really big part of the consideration of the facade design for this building.